right? So
Um,
yeah.
so I've got another theory here. We were looking at the first 10 documents and the next 20 and the next 30. So the
Mhm.
first 10 which are returned, we look at the precision and say we construct a graph of the precision versus the document number. So for the first 10, we should have a very high precision value, and that would keep decreasing as the number of documents increase. I mean, not a very steep decrease, but slight decrease.
So you're saying it'll look like this, something like
Yeah,
this.
yeah.
Okay, but you're going to get this kind of some kind of a curve for one search engine, but you'll get a different kind of a curve for some another search engine.
For another search engine.
So you're
So
how will you compare the two?
the level of precision in one with the level of precision in another.
And at
How
what point will
precise
you
are the
measure?
first?
And at what point will you measure? So because this is an entire curve, right? So when you say you will measure the precision, are you can you be a little more specific?
Yeah, so we basically have users looking at the first 10 or the first 20 documents for any search.
Yeah.
So we try to measure it over an average of the first 10 results
Hmm.
or the first 20 results.
Okay. So let's say this is the average over the first 10. This is the average over the first 20. Um,
We can take an average of both of these points for one search engine, and then the same can be done for another search engine.
yeah. So that's a reasonably good way of doing this. What was your name, by the way?
Priyanka.
Okay. So yeah, this is a simple way of comparing the values of the performance of two search engines. You measure precision at specific points. I mean, the simplest possible thing that you could do is you just look at the first 10, that is page 1 of your return results. See how many documents are relevant. Do this for Google, do this for Yahoo, and then see if and don't think about gradations right now. Just think of marking each document as relevant or not relevant. And you do this for both search engines for the first 10 results and see which one of them has a higher precision. Of course, you won't use a single query. You will probably do this over many queries and then form some kind of a conclusion. Okay. So um, that's one way. Another way is to not just look at the first 10 results, but to look at the first 20 results also, the first 30 results also, compute the precision values at all these points, and then take their average and compare the average for the two search engines. So let me ask one question here. Why are we measuring only precision? Why not recall? What happened? Because we were looking at both precision and recall earlier, right? So now you're saying that we should look only at precision.
Yeah,
Is
because
there a... Mhm.
recall in any case is incremental. For every 10 documents, 20 documents, recall is going to increase.
Okay, but it may increase at different rates, right?
Mhm.
So the value of k, whatever we have chosen,
Mhm.
would very likely be very small as compared to the number of relevant documents for most queries. So that could be like one reason.
The value of k could be...
Very small as compared to the number of relevant documents for any query. So the recall would be very close to zero for at least the first 10, first 20, first 30. Until you get a reasonable number, the recall would be close to zero for sure. Like that.
Okay. Okay, that's one way to look at it. In the context of web search, I mean, one way to answer the question is like this. In the context of web search, precision is what really matters more. I mean, in other contexts, like in the context of Westlaw that we saw earlier, recall was more important than precision. So it was okay for a rank retrieval system for Westlaw to return irrelevant documents because the lawyers don't want to miss any document that could pertain to, some particular case against a company, for example. But in case of web search, we don't want uh, irrelevant documents near the top. So that's one way you can argue we'll measure the precision. And what you're saying is that the recall will anyway be very close to zero, because if the number of relevant documents in the collection is, say, in the millions, then just by looking at the top 20 or 30, um, we may not be able to get a significant difference, at least in their absolute values, right? Is that what you're saying?
Yes, sir. Yes. Like so the recall would be like, would surely have to be low if you're looking at only the first 10, first 20, until we get a
Okay,
size of number.
but I mean, think about this. It's not really the absolute value of recall that matters, but it's mostly the relative value. So let's say we ignore the denominator. Okay, so uh, instead of computing recall because the denominator will be the same for both uh, search engines, right? Because they are operating on the same corpus. So
Yes,
for a
sir.
particular query, the number of relevant documents in the corpus is fixed. So let's say we ignore that value from the denominator of both search engines. Then the numerator values will just be integers. They'll correspond to the number
Uh,
of
Excuse me,
relevant
sir.
documents. Yeah.
So there was a break in the noise. Could you please repeat? Break in the voice, sir, please. Could you please repeat?
Okay. Sure. So what I'm saying is the recall is measured by the number of um, the number of relevant documents that are returned. Okay, let me just call it some numerator divided by some denominator. This denominator is the number of relevant documents in the corpus, and this is a large value compared to the number of relevant documents in the top 20 list, right? What I'm saying is, let's ignore this denominator, because the denominator will be the same for both search engines. What if we compute the numerator only and compare the two?
Sir, isn't that happening in the precision also? Because we're all
Exactly. So that is actually what's happening in the precision. Because when computing the precision, what are we computing? We're computing the total number of relevant documents in the top 20 divided by 20. Right? That's what the precision is. And again, if we ignore the 20 thing from both the numerator and the denominator, we get something identical in the numerator. Right? So we don't need to measure the recall separately here, because just by computing the precision, we know that if the precision of one search engine is higher than the other search engine for the top 20 documents, then the recall will also be high. Is that clear?
yes, sir.
Is that clear to everyone?
Y-
Say yes.
Okay.
Yes, sir.
Okay. So if you note, this particular way of evaluating a score for a search engine will will rank a search engine higher than another just based on the top 20 or so results. Right? Suppose you want to also consider results that are further down. Then what would you do? let's say you want to compute some measure which incorporates the performance all the way up to the end, not just at the very beginning. But I mean, you can ask, well, why do that? Because we won't be looking at results beyond the top 20 or 30. And sure, I mean that's a reasonable argument. But let's say there is a scenario where you are concerned about the overall ranking, not just about. I mean, you definitely want to give weight to what's happening in the region here, but you also don't want to completely ignore this zone, this particular region where you have documents say beyond position 1000 or so how would you modify your score to incorporate all of them? There's no one single answer. I mean, again, I'm just trying to get you to think about how you will be evaluating the performance of your system if you were to actually build that and have this kind of a requirement. If your requirement is only that you want to optimize the results in the top 20, you could do that, but it's possible that you could end up performing pretty badly with relative to the other search engines on what follows, right? So suppose you want to come up with a measure which gives weight to the distribution of relevant documents all the way through. So clearly overall what do you want? You want a better search, you expect a better search engine to have the relevant documents bunched up as close to the top as possible. Right? In fact, in the ideal case, you want all relevant documents to appear. If there are, let's say J relevant documents, you want them to appear in the, in the list in the order from 1 to J in decreasing order of score. And then you'll have all the, actually you won't even have the documents that are not relevant uh, in your list. That's the ideal scenario. But in reality, you're going to have documents that are not relevant interspersed in between. And what you ideally want is, what you realistically want is to have those non-relevant documents be present more towards the bottom and the relevant documents present more towards um, the top. So how do you come up with a score to measure the distribution as a whole? Right? So you want one search engine to rank better than the other if that is the approximate distribution. The relevant documents are bunched up to the left, and you want to penalize the search engine where the relevant documents may be not necessarily bunched to the right, but scattered. Even if it's scattered uniformly all the way through, that's still not as good.
Multiply that by 1 by 10, and then number of relevant documents are 20 by 1 by 20, and then so on and so forth up till whatever number you want to go to.
Sorry, your voice got cut off in the beginning. Can you repeat that?
Yes, so like if the number of the precision which we measured at number of at 10 documents multiplied by 1 by 10 plus the number of the precision by measured at 20 documents multiplied by 1 by 20, and then so on and so forth up till whatever measure you want to go to, because then the fewer the result, it's getting more weight. Like at lower number of results, it's getting more weight.
At lower number of results, it's getting more weight. Yeah. So that means results that are ranked closer to the top are getting more weight this way. Sure. I mean, you can think of weights that are larger for documents near the top. Um, Here's one other way to do this, slightly different way. By the way, how long do you want to continue doing this? You said this divided by 10 plus the precision here divided by 20 plus the precision here divided by 40. How long do you want to continue?
Till any like based on some survey up to how deep the users are willing to go usually, like something like that.
Okay. What is the maximum point up to which you may want to go? Beyond which it doesn't matter whether we continue beyond that point.
So like the number of time, I mean, let's say 100,000 or something like that. Beyond that.
Can you be like can you be a little more specific in terms of so let's say n is the total number of documents, j is the number of relevant documents in the corpus. Uh, so actually I'm not asking for a figure, I'm more asking for the point beyond which you can say that I'm going to stop.
So I have one answer, then another person also has an answer. So so maybe I mean I was thinking that it would be based on the user, like how much time he's willing to spend then on the document size. Okay, there's one more. There's one more person, sir.
Yeah.
So we don't want the precision to fall beyond a certain point. So while we are going down in this particular graph, say we have a benchmark of the precision that at this particular point, I mean the precision should not
Actually,
go down beyond that.
so if you want to compare two search engines, may want to allow the precision because that's what will detect the search engine is a bad one. Right? Let's say the other search engine won't go down, like precision of the other search engine remains relatively same.
Excuse me, sir.
Yeah.
So your voice is cracking. So can you just repeat what you said?
Okay. Uh, maybe you can turn off the microphone for a second. Yeah, thank you. What I was saying was, you're saying that the cutoff point here will be a point where the precision dips below a certain value. And what I'm saying here is that since you're comparing two different search engines here, you have to make sure that you're consistent in that cutoff point because um, you're after all comparing two different scores, right? So if you're going to cut off when the precision falls below a certain value for one of the search engines, but you will be continuing computing it for the other search engine, that may not be a fair comparison. So let me ask you this. What happens, so let's say there are j relevant documents in the corpus, okay? Now suppose all j of them, let's say the top 10 documents have 8 or 9 of them, then the next one have 7 or 8 of them and so on. And let's say all the j documents appear up to some particular rank. Okay, I'll just call this rank as R. So at position R in the rank list, the very last of these j documents appears. Is there any point in continuing beyond this point? By the way, the ranking in the other search engine may be different, right? So the other search engine may not have the last relevant document appearing at rank R. It could be before, it could be after. So anyway, let me throw this idea. This may not be so obvious to you. So let me mention it. Um, suppose I compute 10 precision scores, but I'm going to compute the 10 precision scores at the following 10 values. Instead of 10, 20 and so on, I'm going to compute the precision at recall equal to 0.1, at recall equal to 0.2, recall equal to 0.3 and so on until recall equal to 1. Okay, so this is the point at which recall becomes 1 because all the relevant documents are now ranked within this zone. So beyond this point, the recall will stay 1. Okay, so at recall equal to 0.1, what was the precision? At recall equal to 0.2, what was the precision? At recall equal to 0.3, what was the precision? And so on. You get 10 precision values. You can average them, or you can give this one a higher weight. I mean, you can come up with a variety of formulae to combine them all into a single score. But by doing this, effectively you're ensuring that you will have exactly 10 values to compare, right, in both search engines. Right? If you have an unequal number of values, that may not be a fair comparison. So you take 10 values from here, give them, some fixed distribution of weights that you will also use for the other search engine. And then by doing this, you're ensuring that you're covering, your score is giving due weight to all documents right from the beginning, at the very beginning of the list, going all the way up to the very end, at least as far as the the end of the relevant zone, at which you've collected all the relevant documents. This is another, there are many different scores you can think of, but this is what is usually done. Now, actually, if you ask when exactly does the recall become 0.2, because it's not necessary that the recall will be exactly 0.2 at some point. So obviously, you will have some kind of a precision recall curve which will go down like this if you just plot it as a uh, as a function of the number of documents you are considering in your ranked order. Initially the precision should be high, and then it's going to go lower, lower, lower. So this is the precision, and this is going to be the recall. Okay, in fact you can have vertical lines also. This actual curve is going to be very, very jagged. You can have a drop, a vertical drop also. Why? Because when if the next document that I consider is not relevant, then the recall will remain the same and the precision will go down. So you can have a vertical drop. Right? So this is the point at which you start, where you look at just the first document and you compute the precision and the recall based on just that. And then you look at document number 2, and then you'll have another score for 1 and 2 combined, and then for 1, 2 and 3 combined, and so on. So this will be in general a very jagged curve. And what you have to do is you have to smoothen this first, just so that you're not biased by these fluctuations. You'll have to smoothen this first and then pick the values. So this is recall equal to 1. This is where you stop. Then you pick 10 values distributed, I don't know, maybe uniformly 0.1, 0.2, 0.3 and so on, and then you can give them unequal weights and then compute it. I think we're out of time, but I hope you've got a sense of the different possibilities that there are. You can have, the actual formulas may even be far more complicated than this, but if you are able to think about these different scores and think intuitively about what's happening, I think that's good enough. So at the end of the day, I hope from this lecture you've learned how to compute roughly a single score value for a search engine's performance that you can then use to sort of compare one search engine with another, or to compare your search engine, the one you build, with some reference track collection performance metrics. Okay, and if the performance doesn't end up being so good, then you can modify the decisions that you took, the design techniques that you took to design whatever system you